Okay, so in this second part of our lecture on stack, we're going to take more applications of stack, particularly those related to a type of expression called postfix expression. Okay, expression like the one we are seeing above is actually called infix expression. This is the one we are used to. Okay, it is called infix because the operators, the binary operators, they always appear between the two operands. Okay, so here plus is between 5 and 9. So we want to add 5 and 9. Similarly, times here is between this bracket and 2. So we are going to try and multiply the result of this bracket by 2, and so on. This is called infix expression. Now, in infix expression, there is a rule that you have to follow to evaluate the expression. There is what is called precedence rule. As you all know from higher school, you cannot do addition and subtraction until you finish with division and multiplication. Okay, if you have to override that rule, then you have to use parentheses, okay, to indicate that this has to be done first. So for example here, because of this parenthesis, we can do this addition first before we attempt to do the multiplication. But otherwise, we have to always do the multiplication and division before we do addition and subtraction. Okay, so this is what we are used to. However, there is another type of expression which is called postfix expression that is in fact much easier to evaluate, especially for the computer, than infix expression. Now, a postfix expression is the one in which the operator will come after the two operands. Okay, yeah, so the good advantage of postfix notation is that the order of evaluation is always unique without the need for precedence rule and without the need for parentheses. Okay, so the two rules or the two conditions that we have to observe in the case of infix, we don't have them here. There is no precedence rule to observe. Also, postfix expression, they don't have brackets at all. There are no parentheses. And the expression is always evaluated uniquely. This is why they are computer friendly. So in fact, most compilers, before they try to evaluate your arithmetic expression, normally they will convert them to postfix, then they will do the evaluation. Okay. Let me show you examples of postfix expression compared to infix. Okay, so here, for example, 16/2, which is infix, will be represented in postfix as 16:2/. Okay, as you can see, the operator is after the two operands, whereas in infix, the operator is in between the two operands. Okay, similarly, this infix, 2 plus 14 times 5, in postfix is 2, 14 plus 5 star. I will show you how to do the conversion in a moment in the next slide. So again, this infix is represented like this in postfix, and the last one is represented like this in postfix. Let us see how actually these postfix are obtained from the infix, as shown in the next slide. Okay, so the following example shows how to actually manually convert infix expression to postfix expression. The first example is straightforward because there's only one operator. So to convert it to infix, just move the operator to be after the two operands. So instead of 16/2, it's going to be 16 2/. Okay. Let's take the second example. Here you have more than one operator. So actually the way to do it is to follow your normal infix precedence rules. As we know that in infix we have to finish with the bracket first, and therefore just go and convert this bracket to postfix. Therefore instead of 2 plus 14, you will have 2 14 plus. Okay, so underline that to indicate this is now one term. 2 14 plus, think of it as one term. You have to do times 5 with that term. Okay, so basically you have a term times another term. Okay, to convert that to postfix, just you need to take the operator to be after the two terms. So you're going to have 2 14 plus as one term, 5 as the second term, and then the operator times will be at the end. So this is the conversion of this infix to that postfix. As you can see, postfix has no parentheses at all. They always don't have any parentheses. And as we're going to see later, they can be evaluated uniquely. Okay, let's take the next example. So here we have 2 plus 14 times 5. How do we convert it to postfix? So again, the idea is to follow your precedence rules. We know that we cannot do addition until we finish with multiplication. Okay, because this time there is no parenthesis. Therefore, keep this 2 plus for the moment. Let us convert this multiplication to postfix. In postfix, it's going to be 14 5 times. So just underline it to indicate this is one term. Okay, so now 2 plus that term will be 2 14 5 times, and then the operator plus will go at the end. Okay, so this is the conversion of this one to postfix. You can see this and this are completely different. Okay, even though here they look the same without the brackets. Okay, this is why postfix always give you a unique expression. The next example, 6 minus 2 bracket times 5 plus 4 bracket. So again here, follow your infix rules. You have to do the brackets first. Okay, since we have two brackets, we can take them simultaneously. The first bracket will give you 6 2 minus as one term. Keep the times for the moment as it is, but do the other bracket. The other bracket will give you 5 4 plus. Okay, so this is the 5 4 plus. So now we have two terms, one term times another term. To convert to postfix, just have the two terms and then you have the operator times at the end. This is exactly what we have. So this is how to convert infix to postfix. Now the big question is there a way to do this conversion automatically from infix to postfix? As you will guess, of course, the answer is yes. And stack actually is going to give us a very easy algorithm to do this conversion. Okay, so that's what I'm saying here. The answer is yes, with the help of a stack. So actually we're going to see two algorithms related to this infix. One is an algorithm to do the conversion. So if you are given an infix, how do you convert it to postfix? Another algorithm which also uses stack is, suppose you are given a postfix expression like this. How do you now evaluate it to get a value? Okay, Okay, so let us examine the first algorithm, the one that convert infix to postfix. Okay, so here we're going to be reading our input, which is going to be an infix expression. And as we know in infix, you can think of the type of characters you're going to read as one of four types. A character that you read from infix could be a number, or what we call an operand, and it could be an operator, or it could be a left parenthesis or a right parenthesis. So those are the four types: number, operator, left parenthesis, and right parenthesis. Now our algorithm will have to handle each of these cases depending on what type it is. Okay, good. So we examine the characters one by one. This is what the first line here says. Examine the next input in the next element in the input. Okay. 1. If it is an operand, meaning if it is a number, just output it. Remember, we are trying to generate a postfix expression as our output. So if we read a character from an infix and it turns out to be a number or an operand, just put it in the postfix expression you are trying to generate. Just output it. Good. 2. If it is an opening parenthesis, so the input you read from an infix is an opening parenthesis. So in this case, just push it on the stack. Okay. 3. If it is an operator, so here you have a decision to make. Okay. Now here, actually, there's a very easy rule that we should all remember. If you understand this rule, you can understand this algorithm very easily. The rule is that in the stack, we can only have a higher precedence operator on top of a low precedence operator. So for example, if in the stack you have plus, then on top of it you can put times or slash for division, because these are higher than plus. That is only what is allowed. You cannot have a lower precedence operator on top of a higher one. In fact, you cannot even have two operators that are of equal precedence, like plus and plus, or plus and times, or times and slash. You cannot have one of them on top of the other. Only higher is allowed to go on top of lower. So this is the situation we have to resolve in this case number 3. If you meet an operator, you have to check if what is on top of the stack is a lower precedence operator, then you can push it. Otherwise, you have to bring out that low precedence operator from the stack and output it before you can push this higher precedence operator. So this is actually the most important rule to remember. So let's read on. It says if what you just read is an operator, then there are a number of cases. Case 1, if the stack is empty. So in that case, you will not be violating any rule if you just push the operator you just read on top of stack. If the stack is empty at this point, just push your operator. 2, if what is on the stack, that is at the top of the stack, is an opening parenthesis, so again, you are not violating any rule, just push your operator. So an operator can go on top of opening parenthesis, even if there are other operators below that opening parenthesis, no problem. Okay, we're not violating the principal rule. The third case is if the operator you just read has higher priority operator than the one on top of stack, then again you will not be violating any rule. Just push your higher precedence operator on top of stack. However, if it is not the case, so the one in the stack is either equal or in fact higher than the one you just read, then you have to pop the operator from the stack, output it, and then go back and repeat step 3, I should say. Repeat step 3. Okay, this is the idea. The next case, what if you read a closing parenthesis? So if you read a closing parenthesis, this is the last case because we have operand, we have opening parenthesis, we have operator, and now closing parenthesis. So if you encounter a closing parenthesis, you need to pop all the operators from the stack and output them until you meet the corresponding opening parenthesis. Now that opening parenthesis, you also have to pop it out, but don't output it because we don't have brackets in Postfix. Just discard the opening parenthesis. Okay, this is the idea. In case there is more input, you're gonna go and read it and repeat the process. Okay, if there are no more inputs, then we are done. Just pop the remaining operators from the stack and output them, and your output will be the corresponding postfix expression generated from this infix expression. This is the algorithm. Now, the best way to understand this algorithm actually is with an example. So we're going to take an example and see how it works. We're going to solve this infix expression, try to convert it into postfix. Okay, so we're going to take the character one by one. Here we will be showing you what is the output, and in this middle column we will see the content of the stack. Okay, and this first column will contain the first character that we read, or the next character that we read. So we read 2. Okay, 2 is an operand, is a number, therefore just output it. Okay, next we read a star. Star is an operator. Okay, and our stack is empty, so we will not be violating any rule if we just push that operator in the stack. Next is 3. We're going to output it. So in the output we have 2 and 3. Okay, next is slash. Now this is very important. Slash is an operator, and the one in the stack has equal precedence with slash. So we cannot push slash on top of times. What we have to do is we have to remove the times, output it, then we can push the slash. So this is actually what you have when you read slash. You can see the times has been output, and now the stack has just the slash. Okay, next is opening parenthesis. Opening parenthesis, we just push it. Anytime you meet opening parenthesis, just push it in the stack. So our stack now will have 2 items, slash at the bottom and opening parenthesis at the top. Okay, then we meet 2. 2 is a number, we're going to just output it, as you can see here. Minus. Now this is interesting. Minus is an operator. Now what is at the top of stack is left parenthesis. Remember, we say we can push any operator on top of left parenthesis, even though below that left parenthesis there is a slash operator which is higher than minus. But our concern is what is at the top of stack. top of stack is opening parenthesis, so we can push our minus. Okay, next is 1. 1 is a number, just output it. So it's here. Now we meet the final case, number 4. We have not encountered this before. Closing parenthesis. We have made operators of numbers and also the left parenthesis. So when you meet a right parenthesis, what do? You're going to pop out all the operators until you meet the corresponding left. So we're going to pop out the minus, output it, pop out the opening parenthesis here and throw it away. Don't put it in the output. So in the stack, we're going to be left with just the slash. Okay, so this is what you have. You can see the minus has been output, and now the stack contains only the slash. Next is plus. Now here is another issue. Plus cannot go on top of slash, so we have to bring out the slash, and then we will push the plus. Output the 5 is a number. Now this is interesting. When we encounter times, it has higher precedence than plus, so actually it can go on top of it. So we're gonna have plus times. Okay, 3, you're gonna output it. Okay, and this is the end of our expression. So all we have to do now is to pop out anything from the stack and output it. So times will be the one will be pop out first, and then the plus. Therefore, your final answer is this: 2 3 times 2 1 minus slash 5 3 times plus. If you go and do this manually, as we did in the other examples, you will see that we get this exactly. Okay, so this is the algorithm that converts infix expression to postfix with the help of stack. The next algorithm is for evaluation. Suppose we have a postfix expression. How can we evaluate it to get a single value? Again, this is possible with the help of stack, and the algorithm is even easier than the one for the conversion. Okay, so the following algorithm uses a stack to evaluate a postfix expression. So we start with an empty stack, and for each item we encounter, this time there are only 2 types of items. An item is going to be either a number or it's going to be an operator. There will not be any left parenthesis or right parenthesis. So this is why this algorithm is easier actually than the other one. You just handle the 2 cases. Now, if the item is a number, what you do is you push it in the stack. So this is the difference between this algorithm and the other one. In the other algorithm, we don't push numbers, we push operators. But this one, we push the numbers, we don't push the operators. So if you encounter a number, just push it in the stack. Okay? On the other hand, if what you encounter is an operator, then you have to pop 2 numbers from the stack. Apply your operator on them, get a result, and push that result back in the stack. Okay, so this is what is being said here. Pop 2 operands from the stack, apply the operator on the 2 operands. So if the operator is times, you have to times the 2 numbers. If it is minus, you have to subtract the 2 numbers, and so on. The result you're going to get, push it back onto the stack. And basically that is the algorithm. Okay, at the end of the algorithm, you should have only 1 value in the stack. Pop it as your result. So here say pop the only 1 number from the stack as your result. There is one point I need to emphasize with respect to applying this operator on these two operands. Because as we know, A minus B is different from B minus A. So when you pop two numbers, how do you actually apply the operator on them? Okay, if you follow this simple principle, you will always get it right. The first one that you pop should always go to the right of the operator. The second one that you pop should be the one to go to the left. Okay, so if in the start you pop out A first, then B, and the operator is minus, your expression should be B minus A. The one you pop should always go to the right. Get the result and push it back in the stack. Again, we're going to see an example of this to see how this algorithm will work. Okay, so this is an example. So consider the following postfix expression: 2, 10 plus 9, 6 minus slash. This is actually obtained from this infix expression. Okay, and we want to know how to evaluate this expression. Okay, you can see the evaluation should actually give us 4, because this, according to Infix, we have to do the bracket first. So here we will have 12. On the right hand side we have 3. Then now we have to do 12 slash 3, which will give us 4. The question is, if we follow the algorithm we just described in the last slide, can we get 4? Well, let's try and see. We're going to follow the algorithm character by character. So we meet 2. 2 is a number. According to the algorithm, just push it in the stack. We meet 10. 10 is a number. Just push it in the stack. Okay, but when we meet plus, we have to pop the two numbers off the stack, apply the plus on them, and push the result back. Okay, now for plus, it doesn't really matter which one you take to the right and which one you take to the left, but for consistency, always the one you pop first should go to the right, then the plus, then the one you're going to pop next will go to the left. So basically you're going to have 2 plus 10. 2 plus 10 is 12. So push the 12 back in the stack. Push the result back in the stack. Okay. Then continue your processing. Next number is 9. 9 is a number, so just push it in the stack. 6 is also a number, just push it in the stack. But when you meet minus, you have to pop the 6 and the 9 and do the minus. Now here you have to be very careful, because obviously 9 minus 6 is different from 6 minus 9. Anyway, the one you pop first is going to be 6, so it should be to the right. Then minus, then the one you're going to pop second, which is 9. So basically you're going to have 9 minus 6, which is 3. So push that 3 back in the stack. The last item you will encounter is slash. So again, it is an operator. So you have to pop the last two operands in the stack, apply the operator, and push the result back. So we're going to pop 3. It will be to the right, then slash, then pop the 12, it's going to be to the left. So basically we have 12 slash 3, which is 4, and push the 4 back into the stack. Okay, and we have reached the end of the expression. Therefore, just pop out your only element in the stack, which is 4, and it's going to be the answer. This is basically how this algorithm works. In the lab, we're going to try to do at least one of this algorithm as a task. And this brings us to the end of our discussion on Stack and its many applications. Thank you very much.